welcome to the session. I hope I'm audible. I see five learners in the class. So, hello everyone, very good morning. And so we'll start discussion about algorithms, about data structures, and how do we calculate the running time. Right. So we'll shortly get started. Let's just wait for a couple of minutes for more learners to join, and then we'll get started. Okay, so graph representing big O, theta, and omega is not clear. No worries. So guys, I'll just cover all of this. And the other thing is that when we are going through the data structure session, right? Feel free to ask your doubts. Right. We don't have a lot of sessions, so we cannot go very deep into all the topics. Right. But as far as possible, and whatever time that we have, we'll try to utilize it to the fullest. Okay, so I think we can get started. Let me just start sharing my screen. Okay, guys, can you see Miro here, the Miro whiteboard? Okay, fine. So let's get started, guys. So first of all, today, right, what we are trying to do is, first of all, we will talk about asymptotic notation. So what are asymptotic notations? Now, this is the first topic. After that, we are going to look at some real world algorithms, right? And we'll try to understand what is the running time complexity of those algorithms, right? And if time permits today, we'll also look at some of the sorting algorithms, and we'll try to figure out what are the time complexity. Now guys, see this, just to gauge where the audience is coming from. How many of you are still in college? Can you write a me in the chat, those who are still in college? Okay, fine. How many of you are looking at this topic from an interview perspective? Can you write a me in the chat who are looking at this topic from an interview perspective, so that they can apply to other companies, or those who are beginners and they are preparing for interviews? Okay, only three people. Okay, four. What about others, guys? Come on, please be a little bit more responsive in the chat. Okay, so I think mostly people are looking at this topic from an interview perspective, right? That you might be asked questions and uh, related to the topic. Okay, fine. So guys, see this. I'll also tell you where these topics are more commonly used, right? Let me just tell you that as well. So the definition or the bookish definition, right? This is more useful when you are going for college exams and all, right? So this asymptotic notation, how does it look like on a graph and all that, right? So this becomes more useful. But when you are preparing for interviews, then real world sorting algorithms and all the other algorithms that we are going to study as part of this course, right? That is when they become more important, right? So just keep this in mind. Okay, now let's quickly get started, right? And let's understand what are algorithms. So first of all, nothing but, let's say, a sequence of steps to solve a particular problem is an algorithm. Now, you can solve a problem in multiple ways, right? Just think of any problem around you, not necessarily a computer problem. You can solve it in multiple ways. You can either take a lot of time to solve that problem, or you can follow a complex approach to solve that problem, or you can take a simpler approach to solve the problem, right? And that will require lesser time to do that, right? Very easy example is that you can, let's say, if you want to order something from a restaurant. Okay, so if you want to order something from a restaurant, there are multiple ways available today, right? Either you can go take a dine out order or a takeaway order and come back to your home, or what you can do is you can just order it through Swiggy or Zomato, right? But there is a cost involved, right, in both the cases. So when you go and take the order, right, then what happens is your time that is needed is more, right? So time is more, right, but the money is less because you save on the delivery cost, maybe, right? That is a consideration. Similarly, when you order via Zomato, your time that is being taken is very less. All you need to do is you need to order and then receive the order, but the cost might be more because of all the delivery costs and the taxes that Zomato takes. Now, similarly, when you solve a computer problem, there are two things that can impact or can be used to determine how efficient is your solution, right? So one is called the time complexity and the other is called the space complexity, right? Now guys, whenever you will go for interviews, right, most of the times they're not going to ask you the bookish definition of what is big O time complexity, what is big omega. All of this will not be asked. Okay, what will be asked is you will be asked to solve a problem, right? And then you will ask to determine what is the time complexity of that problem, right? And when you are asked to determine the time complexity of the problem, most of the time we find out the time complexity of the problem with the big O time complexity. Okay, so let's understand this. How do we find the time complexity of a problem using the big O time complexity? So let's understand this, right? Now also the other thing is, guys, that whenever you write a program, right, the program can be written in two ways, right? So first way, you can write it in the iterative way. I hope everyone understands the difference between iterative and recursive. Yes or no in the chat, guys? Guys, no? How many of you don't understand the difference between recursive and iterative? Come on, everyone, yes or no? Okay, there are a lot of people with a no. Okay, so guys, is this your first interaction with DSA, or have you gone through some DSA lessons before in Upgrad? First or not? This is the first interaction. Okay, a first interaction for many people. Okay, got it. Sure. Cool. So see this, guys. Basically, we will be understanding iterative algorithms first, right? We will discuss about recursive algorithms as and when they will come in the course, right? So I hope everyone is aware about for loops, right? For loops, if conditions. Is everyone aware about that? Okay, great. And guys, one last question. On a scale of 1 to 10, how would you rate yourself in mathematics? In the chat, everyone. On a scale of 1 to 10, how would you rate yourself in mathematics? Okay, so a lot of people have given responses. Okay, that's fine. Cool. Now, guys, see this. Let's say there is an algorithm, right? So, how do we determine the time complexity of an algorithm? Okay, how do we determine the time complexity of an algorithm? So, let's figure this out first, and then we will understand what are the different notations. Now, guys, let's take this example. Let's say we have a simple for loop. I'm not using any particular language as of now. I equal to 1, I less than equal to n, I plus plus, and if I do a print of hello, right? Print or console.log, whichever language you have. So there would be a print of hello. Now, guys, can you tell me how many times would this print statement be printed? Any idea, guys? How many times will this print statement be printed? Let me just share the Miro. That would be easier. Yeah. So any idea, guys? I hope everyone can see Miro. Okay, n number of times. Sorry, guys. I think there was a network error. I think my battery died now. Okay, cool. I'll just start sharing again. Yeah. So I hope everyone can see Miro right now. Hello. Am I audible, guys? Hello. Guys, am I audible? Okay, fine. I think the chat hung for a bit. Okay, cool. Let me just start sharing my screen again. Yeah. So how many times will this hello be printed? So everyone is saying n times, right? I hope everyone agrees. Anyone who is not able to understand why this will be printed n times, just message me in the chat. But just see this: I equal to 1, I less than n. So let's say if n is equal to 10. So when I equal to 1, then hello will be printed. I equal to 2, hello will be printed. Up to the time n equal I equal to 10, hello will be printed. Now when I becomes 11, then this condition becomes false, and then hello will not be printed. Right. So this for loop is getting printed 10 times. I hope everyone agrees with this. Okay, fine. Now guys, see this. Let's say if you know what are the different steps in this algorithm? So the first step is to print hello. So whenever we have these kind of simple statements, right, let's just assume that it takes 1 unit of time. Okay, let's just assume that it takes 1 unit of time. Let's call it t. Okay, so let's say it takes one unit of time. Now guys, just think about it. What are the other places in this algorithm that can take 1 unit of time? Right. So initially when you say I equal to 1, that will also take 1 unit of time. When you say I equal to I plus 1, that will also take 1 unit of time. Right. And when you will do this comparison, that will also take 1 unit of time. So any simple operation, right? For example, let A is equal to 10, or this type of operation, any simple operation, we can simply assume that it takes 1 unit of time for our convenience. So just to make sure that you are getting this, let's say if I do something like this, like any statement, for example, a equal to 10, or let's say a plus plus, any where a is any variable, right, where we can say a is equal to false, or any such statement, we can say that it takes 1 unit of time. Okay, for just for our understanding. So in this case, right, what are those statements? So there will be this I equal to 1, this initialization. So let's say it takes t unit of time. Okay, then there will be this comparison. This will also take t unit of time. Then there will be this print statement. So this will also take t units of time. Now this print statement will be called n times. So this will take n into t amount of time. Let's say we are running it 10 times for now. So it will take t into 10 amount of time, right? And then this increment will also happen 10 times. So this will also take t into 10 amount of time. And this comparison will also happen 10 times, right? So this will also take t into 10 amount of time. So we can say this, right, that basically what is happening here is that the total time that this algorithm will take, it becomes 32t. Can we please say that? Right. So this becomes 32t. Okay. Now you don't have to go through each and every statement here. Just see that if you are having a loop, right, what is the innermost statement? So this is the innermost statement. So to determine the time complexity, guys, one hack is you just determine how many times this inner statement would be printed. Okay. So how many times this inner statement is going to be printed? If you are able to determine that, right, you are able to determine what is going to be the time complexity. Now the time complexity is always in the order of input. Okay, so in terms of this input n, you have to determine what is the time complexity of this particular algorithm. So if this statement is getting printed n times, we say that the time complexity here can be big O of n. Now what is this big O of n? We'll understand that. So just understand this, guys, that whenever the input size of an algorithm increases, right, whenever the input size of an algorithm, this is the input size of an algorithm, let's call it n, right, and this side it is the time taken, let's call it function of n. That means that in terms of n, we have to determine what will be the time complexity, or how much time will it take for this algorithm to run. Yeah, I'm sharing screen, Priyanka. So basically in terms of n, we have to determine what is the time that this algorithm will take, and then we have to determine the approximate time. Okay, we have to determine the approximate time. Now guys, just think about it logically. Do you think that when the input size will increase, the time taken to run an algorithm will increase? Do you think this will happen? Just very simple question. See this, what I'm asking you is very simply, I am giving you 100 mangoes, okay, and I'm asking you to divide it among 10 people. So your input is n equal to 100. Okay, so you have to divide 100 mangoes amongst 10 people. Now if I increase the input tab, so that let's say if I give you 1 lakh mangoes, do you think the time it will take you to distribute it will become higher if the number of mangoes is more? And it applies in any real world scenario, right? Okay, so whenever the input size will increase, the time it will take will increase, right? For example, here just see this. When n equal to 10, then it is taking 32t. But when n is equal to 100, then it will take 320t, right? Yes or no, guys? Because see, what will happen is that n is 100, so this loop will run 100 times. So naturally, it will take more time, right? Yes or no? Is it clear, guys? Okay. So what we can say is that, let's say if we have a algorithm whose time complexity is denoted by this graph. Okay. Now, why this graph has this kind of a bump here? So basically, it can happen that for small inputs, right, it might be difficult to calculate the time complexity. Now, why it might be difficult to calculate the time complexity? For example, we can write code like this, right? That inside this for loop, we can say if, let's say, I is less than 10, break, right? So if I is less than 10, break, that means that nothing will be calculated, directly you get the output. So for small inputs, the time complexity may vary, right? But generally the time complexity graph looks like this only. Now guys, let's understand what is the theoretical definition of big O of n and theta of n and omega of n using this particular graph. Okay. Now guys, let's say that this time that the algorithm is taking is a f of n. Okay, f of n. Now f of n can be anything, right? For example, the time that an algorithm takes, if the input size is n, right, the time that the algorithm takes can be n square plus 10n plus 3, right? Or it can be n log n plus 20, or it can be n cube plus 30 n square plus 10, anything. But all of these are functions of n, right? All of these are functions of n, f of n. Yes or no? Because the only variable here is n, right? So all of these are functions of n. So that is what is meant by f of n. Okay. So let's just assume that the time taken by a function to compute is f of n, right? Now, what is the big O notation? So, guys, the big O notation says that if you can find a function, right? If you can find a function c into g of n, right, such that f of n is less than equal to c into g of n. Now, guys, this will be very confusing, but don't worry, you will understand it. Just see this. Okay. For some n greater than equal to n naught, right, for c greater than 0 and n naught greater than equal to 1. Okay. Now, also I'm telling you guys, if you have already passed college, I think you will not need this anywhere else, but it's always good to understand it. So please, let's try to understand it, right? Now, guys, what does it mean is that, just see this here, that here, if I can find a function, if the time complexity is f of n, okay, and if I can find a function c into g of n for n greater than n naught, right, then what I can say is, in that case, I can say that f of n is equal to big O of g of n. Okay, now guys, don't you think this is very, very complex? How many of you think that this is complex? Very complex. In the chat. Now, this is very complex, right? When I looked at it at first time, it was like, what is this happening? I went to study computers, and where are all these graphs and all coming from? No, guys, but this is not, this is not that complex, right? Now, let's just assume, what does this mean? Okay, so let's just see this. Okay, Now let's understand that, let's say f of n, that is the time taking for a function to run for some function, right? Let's say it is 3 into n plus 2. Okay, for some function, the time taking for that function to run is 3 into n plus 2. Okay, this is clear. For some function, the time that is taking for that function to run is 3 into n plus 2. This is clear to everyone? Come on guys, we'll go step by step. Is the first thing clear? F of n is 3 into n plus 2. Is that clear to everyone? Yes or no in the chat? Quickly. That means that if n increases, the time taken by this function grows in the order of 3 into n plus 2. Okay, fine. Now guys, see this. Basically, we have to find the big O of this function, right? We have to find the big O notation of this function. What will be the big O notation? So let's understand this, guys. So to find the big O notation, right? What we have to do is, we have to find a C into G of n such that this condition becomes satisfied. Okay, so what we want to find out here is, if we can find a function, so basically what we have to find, so f of n will be big O of g of n if f of n is less than equal to c into g of n, right? So what does this mean is, guys, let's say if we assume that the g of n is equal to n. For now, let's assume that the g of n is equal to n. Just assume this. Okay, can you assume that g of n is equal to n? For some time, can you assume this? We can assume it, right? Let g of n equal to n. Right? Yes or no, guys? Is this step clear? Can we assume g of n is equal to n? Now you will ask, how did you assume g of n equal to n, right? So what I'm saying is that what you do is, whenever you have a function of this form, right, you just assume whichever is the highest coefficient of n, you assume g of n to be equal to that. Okay, so in this case, this is n to the power 1, right? So we will just assume g of n is equal to n. Now guys, if g of n is equal to n, can you prove that 3n plus 2 is less than equal to c into n for any c greater than 0 and any n greater than n naught? Can you prove this, guys? So now guys, just see this. If I take c equal to 4, okay. Now guys, can you say that 3n plus 2, is it less than equal to 4n? Is this statement valid for any n greater than n naught? That means that, see this, guys, just see this. Is it, when you have n equal to 0, is this statement true or false? Guys, when you have n equal to 0, is this statement true or false? Come on, everyone. Quickly, guys, in the chat, is this statement true or false? It is false, right? When you have n equal to 1, is this statement true or false? Come on, quickly, guys. It is false. When you have n equal to 2, is this statement true or false? Come on. True, right? Okay. When you have n equal to 3, is this statement true or false? Quickly, everyone. It is true, right? Okay. Now, guys, so don't you think I have got my n naught? That means that whenever the n, right, whenever this n naught is greater than 1, whenever the n naught is greater than 1, that means that for all n, right, here it says that for all n greater than n naught, right? So let's say when you say that n naught is greater than 1, then for all n, this statement becomes true, right? For some values it is false. Here if you see, for some values it is false. For 0 and 1 it is false. But whenever this value of n becomes greater than 1, then this statement is true, right? Correct. Okay, so I can say that, right, for c equal to 4 and for n naught greater than equal to 1, I have found a g of n where f of n is less than equal to c into g of n. Is this statement correct? For c equal to 4 and not greater than equal to 1, I have found this, right? Yes or no? Okay. Now, if I have found this, then I can directly say that, right? That f of n is nothing but big O of n. Is it clear? Because f g of n was n, so whenever I find something like this, I can directly say f of n is equal to big O of g of n. Is it clear, guys? Okay. Now see this, guys. If I can say that f of n is big O of n. Okay. Now, how did I get this? So basically, I took g of n equal to n. But guys, don't you think that if g of n was equal to n and I am able to satisfy this, then I will be able to satisfy this for any function which is greater than n, right? For example, let's take g of n now becomes n square. G of n is equal to n square. Okay. And let's say our f of n was 3n plus 2. Getting it? So g of n is n square, f of n is 3n plus 2. So what we have to prove is 3n plus 2 is less than equal to c into n square for some c which is greater than 0. Right. And for some n, right. That means that n can be a very small number, but after that it should increase. So for n equal to 0, this is false. Right. Let's take n equal to 0. This will be false. So n equal, let's take the value of c as 1. Let's take the value of c as 1. So for n equal to 0, it is false. For n equal to 1, it is false. For n equal to 2, it is false. But for n equal to 3, again it is false. For n equal to 4 now, when you see n equal to 4, guys, don't you think now this will become equal to true? For n equal to 5 also, this will become equal to true. Getting it? Yes or no? Come on, guys. Think about it. See, n equal to 4, this will be 16. This will be 14. So it is less. This will be 25. This will be 17. So this is less. N equal to 6, this will become 36. This will become 20. Again, this is less. So I have found c equal to 1 and n naught equal to 4 such that this statement is valid, right? Yes or no? So I can also say that f of n is big O of n square. Yes or no? I can say this, right? Based on the definition. Okay. So guys, in this case, you will see that f of n is not only equal to big O of n, f of n is also equal to big O of n square, big O of n cube, you know, and big O of n to the power 4 and so on. Okay. So that is why in any question, have you ever read this term as tight bound as possible? Have you read this in any DSA question? Solve this using an algorithm having as tight bound as possible. Okay, that means that you can find any c into g of n, right? If you just are asked this question, you can find any c into g of n. So you can find this function also. You can find another function like this also. You can find another function like this also. All of this will be big O of n, big O of n square, big O of n cube. But you have to find the tightest. Okay, so tightest would be if you can find something like this, right? That is the tightest or the closest to f of n. That is what you need. Okay, so that is why they say that as tight bound as possible. Okay, is it clear, guys? What is the meaning of tight bound? Okay, so don't say that, if you have, so just see this, right? For this function, this particular function that I created here, can I say that the time complexity is big O of n to the power 5? Can I say this? Yes or no? Just think in the chat. Now, how did you get n to the power 5? So basically, I told you, right, that how many times will this statement be printed? It will be printed n times, right? So just and take some constant for these kind of things. So you can simply say that the f of n for this function, let's say the f of n for this function, right? So just let's calculate in using very basic terms. This statement would be assigned only one time, so 1 plus this check will be performed n times, so n. This assignment would be performed n times plus n, and plus this print statement will be performed n times plus n. So this would be 3n plus 1. So for a function which is 3n plus 1, can we say that the big O time complexity is big O of n to the power 5? Yes or no in the chat, guys? Come on. Can we say this? Hello, guys, am I audible? Come on, guys. Can we say this? Yes or no? What do you think? Okay, see what I'm saying is, see 3 for f of n is 3n plus 1. Here we took 3n plus 2 example, right? So what I'm saying is when my f of n is 3n plus 1, can I say that for this function or for this algorithm, the big O time complexity is big O of n? Can I say this? Okay, just see this. Can I say it is big O of n? Yes or no? That is what we discussed right now, that we can say this is big O of n, right? Because we can find c is equal to 4, and for 4 it will be always greater than 3n plus 1, right? We can say this. Okay, now can we say big O of n square for this function? Quickly, can we say this? Quickly, guys, in the chat, can we say big O of n square for the same function? What do you think? Come on, everyone, just write yes, no. Either you have to write yes or no. What do you think? Come on, guys, there is no judgment here. You can write anything you want. Come on. Unless we do a proper discussion, we'll not be able to understand this. Okay, so people are saying no. Okay, but guys, see this. What is the definition of big O notation? So if I find, so we are saying that if g of n is equal to n square, right? If we cannot write it like this, okay, then I cannot say that 3n plus 1 is less than equal to c into n square, right? You are saying I cannot write it like this. That means that this statement will be false, right? But don't you think for all n which is greater than, let's say, 4, for all n greater than 4, don't you think this statement is correct? This is correct, right? Guys, just think about it. So for n equal to 4, this would be, let's say n equal to 4 and c equal to 1. C is equal to 1, so this will be 16. And this would be 13. So this becomes true, right? Yes or no? So if this becomes true, then I can write it as big O of n square also, right? And similarly, not only that, I can write it as big O of n cube also. Because if I write it big O of n cube, then I can prove that 3n plus 1 will be less than equal to c into n cube. And what would be that c? So that c would be, let's say c is equal to 1, n is equal to 2. So this would be 8 and this would be 7. Now, this also can be proved. Similarly, 2, 3, 4, all of that, it would be lesser. So I can say it is big O of n cube as well. Yes or no? Right. Now, if I can say it is big O of n cube, can I say it is big O of n to the power 5? Can I say this? Yes, right. I can say it for any n to the power greater than 1. See, basically, guys, if it is big O of n, that means any value that is greater than n, it will be big O of that. यार देखो सिंपल से बात है ऐसे समझो you if you try to understand by this logic, right, that let's say you have 100 brothers. Okay, you have 100 brothers. Okay, in your family. I hope that is not true, but let's say you have 100 brothers, right? And let's say you are the smallest brother. ठीक है, तुम सबसे छोटे हो, right? अब यार एक काम करना है एंड योर फादर इज सेइंग दैट ओनली द स्मॉलेस्ट चाइल्ड कैन नॉट डू इट, अपार्ट फ्रॉम हिम एवरीवन एल्स कैन डू इट. ठीक है, तो यार अब जो है वो काम आइदर योर इमीडिएट यंगर एल्डर ब्रदर कैन डू, और जो सबसे बड़ा एल्डर ब्रदर है वो भी तो कर सकता है ना द सेम काम, राइट? ओनली द यंगेस्ट ब्रदर कैन नॉट डू दैट, राइट? Is it clear? So that is why what I'm saying is that if it is big O of n, anything that is less than n cannot come in the big O notation. But anything that is greater than n, all of that can come in the big O notation, right? Is it clear, guys? Clear to everyone? Yeah, so basically, if you can prove that there exists some function like this, then that becomes the big O notation. But guys, see this, the thing is कि कोई बहुत छोटा सा काम है and your father is saying कि यार छोटे के अलावा everyone else can do it. Okay, everyone else apart from you who is the youngest brother can do it. तो यार वो छोटा सा काम करने के लिए you will send your next brother or you will send the oldest brother. किसको भेजोगे? नेक्स्ट ब्रदर को भेजोगे ना यार, छोटा सा काम करने के लिए उतने बड़े ब्रदर को भेजने की क्या जरूरत? You will send the next brother, right? That is why in algorithms also they say that give as complete or as tight bound as possible. Okay, as complete or as tight bound as possible. Okay, so if I give you this algorithm, guys, although you know that it is big O of n to the power 5 as well, but should you give the time complexity as big O of n to the power 5 or should you give the time complexity as big O of n? We should give it as big O of n, right? Because this is the closest or this is the tightest. इसको बोलते हैं this is the tightest bound. ठीक है? Is it clear, guys? Everyone? Okay, fine. Now, guys, I will give you one statement and based on your understanding, you just tell me whether it is true or false. Okay. I am saying that all algorithms in this world are big O of infinity. Is it true? All algorithms in this world are big O of infinity. Is it true? Yes or no? Yeah, देखो, what does big O of infinity means? That algorithm takes less than order of infinity to execute. अब यार कोई एल्गोरिथम है, if it is giving results, that means it is taking less than infinity. So it is true, right? बात समझ में आया? It's just like saying that कि no matter यार तुम्हारे कितने भी भाई हैं, but all your brothers are less than the oldest man on this planet. So that is true, right? Unless, ठीक है, less than or equal to, so it becomes equal to in the worst case. So yeah, it infinity is like कि it's a non-computable number. So any algorithm that is giving results, it would be less than this. So big O of infinity is true. ठीक है. अब यार एक चीज मैं बताता हूँ, just forget whatever we have studied. But have you understood whatever we have studied till now? Okay, fine. Now guys, see this. Just forget whatever we have studied. Just see this. If you have a f of n in the form n to the power 4 plus n cube plus 2n plus 1, right? अगर इस टाइप का कुछ भी है ना यार, always take the first number और उस पे you can put the big O notation. So just put big O n to the power 4. Okay, so this becomes the big O notation. Is it clear? Very, very simple. You can do it like this. Okay. Okay, now let's say if you have a function like this, f of n is equal to n into n plus 1 by 2. तो इसका big O क्या होगा यार? Can anyone tell me? What would be the big O notation for this? Think about it, guys. अच्छा, n into n plus 1 by 2 क्या होगा यार? This would be 1 by 2 into n square plus, or we can say n square by 2 plus n by 2. यही होगा ना यार, राइट? दिस वन. अब इसमें व्हाट इज द बिगेस्ट कोएफिशिएंट ऑफ n? जस्ट यार देखो, बिगेस्ट पावर ऑफ n, कोएफिशिएंट यू इग्नोर, ये सारे पूरे इग्नोर कर दो. बिगेस्ट पावर ऑफ n इज n square. So what would be the big O notation for this? It would be n square. Is it clear, guys? Okay, now similarly you have to tell me, if I have n into n plus 1 into 2n plus 1 by 6, तो इसकी टाइम कॉम्प्लेक्सिटी क्या होगी? कैन एनीवन टेल मी? It would be big O of, come on guys, think about it. Very good. It would be n cube, है ना? Why it would be n cube? Because यार देखो, इसमें n ये हो जाएगा n square plus n, तो this is nothing but n square plus n into 2n plus 1 by 6. ठीक है यार? तो this would be n square into 2n, ये हो जाएगा 2n cube प्लस, अब यार इसके बाद जो भी टर्म्स आएंगे ना, वो ये एक n स्क्वायर इधर आएगा, अब ये देखो ये 2n स्क्वायर इधर आएगा प्लस n स्क्वायर इधर आएगा. तो सबसे बड़ा टर्म तो यही है, यू हैव टू 2n क्यूब. अब 2n क्यूब का यू इग्नोर द कोएफिशिएंट, तो दिस वुड बी बिग ऑफ n क्यूब. इज इट क्लियर एवरीवन? यार देखो, यहां तक तो यू विल बी एबल टू अंडरस्टैंड, ठीक है? बट ऑलवेज दीज एल्गोरिथम्स will not be in this form, right? For example, what I am saying is कि always it will not be a apple to oranges comparison कि हाँ यहाँ पे n square है, n cube है, कभी कभी और भी terms आ सकते हैं, right? So I hope, let's dive deeper into this topic, but I hope this is clear to everyone, right? Yes or no? Whatever we have studied till now, is it clear? Okay, so guys, just think about it. Big O notation. This is how we get the big O notation, right? And today we will practice a lot of other algorithms as well. I want to give a little bit more time to this topic because this is the base for data structures and algorithms. Without this topic, we should not move forward until and unless you have understood it clearly, right? We should not move forward. Okay, so we'll give it a little bit more time to understand, and then only we will proceed further. Okay, cool. So let's take a short break, guys. I think the information should not get overloaded. So we'll just take a short break. Okay, I'll also launch the mid-session poll. So please attempt the mid-session poll, guys. Right. If you have any subjective feedbacks, please put it in the comments. I'm assuring you that if you have any valid feedback, right, all of that will be taken care of during these sessions. Right. So anything that you want to be changed or you want to be improved, please put it in the chat. Okay, I think Karthik has his hand raised. So Karthik, I'll just let me stop this poll and then I'll come to you. Okay, I'll stop publishing now. Yep. Yeah, Karthik, go ahead.
Sorry, it was clear now.
Hello.
It was clear now for me.
Okay, okay, cool. Okay. I'll just end the mic access. Karthik, I cannot see you in the list of learners. Are you there? Just a moment. Yeah, Karthik, I cannot see you in the list of learners, so I cannot unmute you. Can you just rejoin the session or? Uh,
Yeah, sure, I'll rejoin.
yeah. Okay, by the way, guys, which places are you from in India? Can you write it in the chat, everyone? We are so diverse. You know, I always, the first question that I ask is, which place are you from? But I forgot. So, okay, Nayanjot is from Guwahati. One of my best students all time is also from Guwahati. Recently got a job in Bangalore. Uh, okay, Dhanya is from Kerala. That's great. That's my favorite state in India. Bangalore, nice. Haryana. Okay, great, Sagar. So, Danya, which place in Kerala are you from? What about others, guys? Oh, you're from Ernakulam. Nice. Rishi, which place in Chhattisgarh? Okay, Bhilai. Come on, guys. What about others? Why is everyone so silent? No one from UP, Bihar, Jharkhand. Okay. No worries, yeah, right. Okay, cool, Rishi. So you're settled in Chhattisgarh. Nice. I'm also from Bihar actually, but I am settled in Kolkata. So Okay, native place is Odisha, but doing job in Mumbai. Great. How many of you are working professionals, guys? What about others? How many of you are working? Not in software field, but in any field. Okay, cool. A lot of working professionals. That's great. Okay, Dhanya is restarting her career. That's good. Actually, for women, there is this back to work program as well that a lot of companies have, right? So you should apply for those positions as well. Because companies also understand that particularly women have to take long break, due to other responsibilities. So whenever you get back, in computer science, it is a bit easier compared to other fields because companies are very open, to take back employees who are, returning from other responsibilities. So just keep that in mind. Cool, guys. So let's continue. Okay. So guys, see this. Basically, I told you that whichever is the largest term, right? In, let's say, if I have a f of n, if I have a f of n, I have already told you that whichever is the largest term, you can take that, remove the coefficients, and that becomes your big O of n. I hope this is clear to everyone. For example, let's take one more practice: n to the power 5 plus n to the power 6 by 100 plus n square plus 10 to the power 9. Now, guys, can anyone tell me what will be the big O of n for this f of n? Okay, can't. Okay, sorry. Let me share. Yeah. So what I'm asking is for this f of n, right? What would be the big O of n? Very good. It will be n to the power 6, right? You take the biggest term, and then what you do is you just put it here. Okay, now see, this 10 to the power 9 is a big number. Okay, 10 to the power 9 is a big number. But guys, whenever we determine time complexity, that is for very large values of n, right? So guys, is, let's say if n is equal to 10 to the power 100, so if n is equal to 10 to the power 100, then 10 to the power 100 to the power 6 is bigger, or 10 to the power 9 is bigger? What is bigger? What do you think? N to the power 6 is bigger, right? Okay, very good. Now, similarly, I just ask you one more question. If f of n is equal to n to the power 5 divided by 10 to the power 100 plus n to the power 4.5 plus 20. Can you tell me what is going to be the big O of n here? Think about it, guys. What will be the big O of n? Here it is n to the power 5, but then it is getting divided by a large number. But here it is n to the power 4.5 without any division. What do you think? What would be the answer here? Think about it, guys. For very large number, what should be the answer? See, the answer would be n to the power 5 only. Why? Because, see, you are talking about very, very large numbers. Okay. You are not interested in small numbers, n greater than n naught. Remember. So you can ignore these part of the graphs. That is what I'm saying. These part of the graphs, right? You can ignore wherein some other n is f of n is higher. But for very large numbers, you have to consider those numbers. So now, if you see this, right? So here, let's consider n, right? Let's consider n to be 10 to the power, let's say, 1000. Okay, now just see this, guys. Is 10 to the power 1000 to the power 5 divided by 10 to the power 100 greater, or 10 to the power 1000 to the power 4.5, which is greater? So if you see this, right? So this would be 10 to the power 5000 by 10 to the power 100. If you know that this can be subtracted, this would become 10 to the power 4900. Okay. And this would become 10 to the power 4500. So which is greater? This is greater only, right? So when you have to ignore the coefficient, any coefficient you have to ignore. Getting it, guys? Because you can increase the value of n to anything. Okay, just to prove that it will increase. So the highest power will always take precedence. Is it clear, everyone? Come on, guys. Is it clear? Yes or no? Okay. Not clear? Array, basically what I'm saying is that here, right? See, n to the power 5 divided by 10 to the power 100, right? You have to ignore any coefficient. So the coefficient here is 1 by 10 to the power 100, right? So no matter how big the coefficient or how small the coefficient is, you have to ignore that and always go for the greatest power of n. So what is the greatest power of n? It is n to the power 5. So just go for that. Okay, clear now? Okay, fine. Now, guys, this is fine, but now it's time to confuse you a bit. Okay, so let's see. If I have f of n is equal to n square plus 2 to the power n. Now, can you tell me what will be the big O of n? Which is bigger? N square is bigger or 2 to the power n is bigger? What do you think? Now, guys, see this. Basically, whichever is bigger of the two, that is what you have to give, right, in big O of n. I hope this is clear to everyone. Which is bigger, that is what you have to give. So basically, you have to decide whether n square is bigger or 2 to the power n is bigger. For all this, it is easier because all of this is power of n. So you know that the highest power of n will be bigger. But here, n square is bigger or 2 to the power n is bigger? Okay, people are saying n square is bigger. Now, guys, you will be surprised, but let's see this. Okay, so this is n square, this is 2 to the power n. Okay, now guys, let's see. Let's take n equal to 5. You don't have to go far. In n equal to 5 only, your answer will be wrong. So what is n square for n equal to 5? It's 25. And what is 2 to the power 5? It's 32. Let's take n equal to 6. What is 6 square? It is 36. What is 2 to the power 6? It is 64. Which is bigger, guys? Two to the power n is bigger, okay? And guys, if you are not able to understand clearly, right, n square or 2 to the power n, which is bigger, if you don't understand this, so what you can do is you can take a log on both sides. Okay, so you can take a log on both sides, and then it would be easier in some cases to determine which is bigger. So guys, do you know this property of log? So whatever is the exponent that comes here, so this becomes 2 log n, and this becomes n log 2. Getting it? So now this becomes 2 log n and this becomes n log 2. So which is bigger? So just see this. So this is always bigger, right? Log 2 is constant and here it is log n and n is getting multiplied. So just take n is equal to, let's say, 2 to the power 3, or let's take 2 to the power 30. Big numbers. So here it would be 2 into, let's say, log base 2. So this would be 30. And here it would be 2 to the power 30 into log 2. This would be 1. So guys, whether 2 into 30 is bigger or 2 to the power 30 is bigger, this is much, much bigger, right? So guys, 2 to the power n is not only bigger than, 2 to the power n is not only bigger than n square, this is much, 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 much more bigger than n square. Right? In a way, it is like comparing Rahul Gandhi and Modi. So this will be Modi and this will be Rahul Gandhi. Getting it? So 2 to the power n is much, much, much bigger than n square in terms of graph. Clear, guys? Is that clear to everyone? Okay, cool. Guys, that was a joke, okay? Any hardcore Congress fans in the chat, please don't take it personally. Okay, is it 2 for third case as well? Which is the third case? Yeah, it will be true for any case here. See, basically, if third case you means whether n square is bigger or 3 to the power n is bigger, right? This is what you mean. Or n cube is bigger or 3 to the power n is bigger. This is what you mean, right? Yeah, this will be true for any n to the power k and 3 k to the power n, right? It would be true always. Just take log. See, 3 log n is bigger or n log 3 is bigger. Right? If you take log base 3, then again the same comparison. Let's say if you take n is equal to 3 to the power 10. So this becomes 3 into 10. And then this becomes 3 to the power 10 into log 3, which is 1. So this is much, much bigger, right? This is 30 and 3 to the power 10 is so huge. 3 to the power 4 itself is 81, right? 81 into 81, you will go into around 6400 something, right? And then add into 3 to that. So this will be around 18,000 and this is just 30. So this is much, much bigger, right? And it will grow exponentially. This is what is called exponential growth. Getting it, guys? Have you heard about this phrase? Someone says exponential growth. That country is witnessing exponential growth. This is what is exponential growth. Okay. So the chart for this, right, if you compare this, so for n square, it is like this, quadratic. Okay. But for 2 to the power n, it's like this. Okay. So it grows very, very fast. So small value of n increase, this chart will grow very fast. N square does not grow that fast. Is it clear? Okay. Now, guys, then so just keep this in mind. Now, one thing that I wanted to tell you is that we don't only have the big O notation, we also have something called as a omega notation and a theta notation as well, right? So let us discuss that as well. What is the omega notation and the theta notation? Now guys, omega notation and the theta notation, right, these are pretty straightforward and pretty much similar. Okay, so what is the big omega notation? Let's understand this. You have already understood the big O notation. So this is how it is pronounced, big O. Okay, now there is this thing called something like this. Okay, this is the big omega. Okay, now what is the big omega notation? Let's understand this. So now, if I have a graph like this, okay, and let's say if I have a function f of n, then for omega notation, right, you have to just find a function let's say this one, such that, now guys, here it is just the exact opposite case of big O of n. Okay, so here what you have to do is you just have to find a function such that f of n, right, here this will always be greater than equal to c into g of n for some c greater than 0 and for n greater than equal to n naught, right? So this is all that you have to do. So जैसे यहाँ पे उल्टा था ना, यहाँ पे we have to find f of n for big O, we have to find f of n should be less than equal to this, but this should be f of n should be greater than equal to this. Okay, now let's say f of n, right, again it is 3n plus 2. Now guys, f of n, if it is 3n plus 2, just think about it. Can I say that, now if this condition is true, then we say that f of n is equal to omega of g of n. Similar to big O, we say that this is equal to omega of g of n. Okay, now guys, just see this. So f of n is 3n plus 2. Now just take any n, any value. Let's say, consider, right, for now let's consider g of n is equal to, let's say, root n. For now let's consider g of n is equal to root n. Okay, now guys, can I prove that 3n plus 2 is greater than equal to c into root n for any value of c? Can I prove this, guys? I can prove this, right? Let's take any value of c, right, constant value, right? So let's say that even if you take very big value, it is only for very big values of n. Let's say c equal to 100. Okay, so we can say 100 into root n is 3n plus 2 greater than that. So if I take very big values of n, right, it would be greater. For example, let's take n is equal to, for our case, let's take n is equal to 100 square. Okay, so this would be 3 into 100 square plus 2, and this would be greater than equal to 100 into root of 100 square would be 100. Right, so this is all obviously greater. Getting it? So I can easily prove that. Okay, so I can say that for this function, the omega is root n. Yes or no? For fn is equal to 3n plus 2, I can say that omega is root n, right? Is it clear? Just like big O, but this is the just opposite. Is it clear, guys? Yes or no? Is it clear, everyone? Okay, now guys, just see this, right? We have to take the minimum. Yes, now guys, can I say this, that every algorithm in this world is omega of 1? Can I say this? every algorithm in the world is omega of n, omega of 1? Yes, right. Because at the very least, it will take one amount of time. See, it is just like that brothers analogy, guys. You have 100 brothers, you are the youngest, right? But I can say that your age is greater than the age of any unborn baby. No matter where you stand in the list of your brothers, but your age will always be greater than that, right? And your age will always be less than the infinity. Okay, so that is why every algorithm in this world is big O of infinity, and every algorithm in this world is big omega of 1. Clear? Guys, is it clear, everyone? Okay, now guys, I can also prove that if f of n is equal to 3n plus 2, then I can also prove that this is equal to omega of n. I can also prove that this is equal to omega of n. Now, how can I prove that? You are saying that, okay, sir, you said it is big O of n, but it is omega of n also. Right, it is also omega of n. How can I prove this is omega of n? Just see this. I just have to prove that 3n plus 2, it is greater than equal to c into n, right? For some c which is greater than 0, for some c which is greater than 0, right? So guys, if I take c equal to 1, then don't you think 3n plus 2 is always greater than equal to n? This will always be the case, right? For any n, even for 0, it is always greater. Right? Yes or no? So I have values of c for which this condition is true, right? So I can also say that this is omega of n as well, big omega of n as well. Okay, now similarly the same thing goes, but guys, big omega is not asked anywhere. Okay, so don't spend too much time on this, only big O is important, right? So just see this. If I have f of n is equal to n to the power 4 plus n cube plus n square plus n plus 1, can I say that f of n, now guys, just write, I want everyone to write a yes or no in the chat. Can I say that f of n is equal to omega of n to the power 4? Can I say this? Can I say this? Yeah, you can. See, it is omega of n to the power 4. Can I say f of n is equal to omega of n to the power 3? Can I say this? I can say this also. Can I say it is equal to omega of n square? I can say this also. And can I say it is omega of n? I can say this also. Right. So guys, just understand this, that omega of n and omega of 1 also, bro. Anything that is like less than n to the power 4, it is true. So just see this. If you have a f of n in this form, anything that is less than or equal to the highest term is the omega notation. Anything that is greater than or equal to the highest term is the big O notation. Is that clear? So similarly here I can say it is big O of n to the power 4, but then I can also say that it is equal to big O of n to the power 5 and so on. Getting it? It is equal to big O of n to the power 6 and so on. Is it clear, everyone? What is the difference between big O and omega? Come on guys, in the chat quickly everyone. Is it clear? Very good. Okay, awesome. Cool guys. So I hope everyone has understood big O, right? But guys, see, this is true for your syllabus, everything. We have covered the topic, we can move forward, but until and unless we do some real practice, right, I don't think we should move forward. So is everyone okay to do some practice, like how can you determine the running time complexity of real world algorithms? Okay, so let's do some practice, guys. But just go through this, right? Take 2 minutes and go through this particular FN, and just take 2 minutes to really think that whether you have really understood the big O terminology and whether you have really understood the omega terminology. Okay, I would suggest you take some time. If you have a piece of paper and a pen, just go through it, right? And try to come up with an analogy. So let's say guys, if I have, so everyone has to come up with this. Okay, this is a assignment, in class assignment. So let's say you have n to the power 4 plus n cube plus 20n. So what will, let's say if this is f of n, okay, and this is n to the power 4. So guys, you already know that what is, I have told you the shortcut, right? So what is the big O of n for this? For this, what will be the big O of n for this? Come on guys, quickly everyone. Very good. It would be n to the power 4. Very good. Awesome. So this would be n to the power 4. So big O of n would be n to the power 4. But guys, now I want you to give me the value of, so basically you are saying that f of n will be less than equal to c into n to the power 4 for some value of c and for some value of n naught. Yes or no? That is what you're saying, right? So I want you to give me the value of C and N naught. What would be the value of C and what would be the value of N naught? Just to check whether you have understood this or not. Can you give me what is the value of C and what is the value of N naught? It is very easy, yaar. You will just figure it out if you write it on a paper. It is very easy. Just give me the value of C and N naught. Guys, come on. What will be the values here? C equal to 1, N equal to 0. Very good. That is the correct answer. For C equal to 1 only you will get it there. You don't have to do anything. Okay. Guys, are you understanding this? See, basically, you have to just say that f of n is this. Okay, n to the power 4 plus n cube plus, I think the value of n is 0. It is less than equal to, for 1 it will be equal to, directly c into n square will be greater. But just see this, right? When you have c equal to 1, then guys, oh, just a minute here, c equal to 1 is not correct actually. Just see this. So you have to prove that n to the power 4 plus n square plus 20n is less than equal to n to the power 4. If you put c equal to 1, then this would just become n to the power 4, right? How is this greater? This is not greater, right? Let's say for n equal to 2, this term will always be greater, right? Getting it? Anil? This is not greater. Okay, so c equal to 1 is not correct. Let's take c equal to 2. So 2 into n to the power 4. Now let's take the value of n as 1. So this is smaller. Let's take the value of n as equal to 2. So for n equal to 2, this becomes 32. This is again greater because of this 20n. Let's take n equal to 3. So for n equal to 3, this would be 81 plus 60 plus 9. So this would be 150 and this would be 162. So now this is the value which is correct. So the value of C is equal to 2 and the value of N is equal to 3. This is the correct value. Is it clear, guys? Come on, guys. You said yes, but now you are not giving the answer. Come on, quickly. Is it clear? Yes or no? Okay, cool. Got it, right? Okay, fine. So let's take one more question then. If you have got it, one more question. Okay, now just tell me this. If I have here, instead of this, if I have 2n square, and here if I have 30n, then tell me the value of C and N. Just tell me the value of C and N. Yeah, see, there can be multiple C and N. Okay, you can have any C and N. You can do it very, very easily also. Just take a very long C, very large C, and that would be much easier to do rather than doing any computation. You can give any value. There are multiple values for this. Come on, can you give me a value of C and N naught for this, where this statement would be correct? Good. So Nayan Jyoti is saying 5 and 5. Okay. Here, see this. Let's say if it is 5 into n to the power 4, and this would be n to the power 4 plus 2n square. plus 30n. So when n is equal to 5, this would be around 400 and this would be around 8. Okay, so when n is equal to 5, this would be 63125. So this will be around 15,000 and this would be around 50. Yeah, so this is much lesser. So that is correct. So when c is equal to 5 and n is equal to 5, this is definitely correct. But guys, do you have to go, just take very large number, right? Let's take c equal to 100 or c equal to 10, even 10. Just take c equal to 10. Now just see this. When c is equal to 10, when even, let's say, for n equal to 1, this is not correct. So n is equal to 30 here. Because of this 30, it will not be correct. But take n equal to 2. So this would be 16 plus 8, 24 plus 60, 84. And here it would be 160. So now this becomes correct, right? So when, let's say, c is equal to 10 and when n is equal to 2, then also this is correct, right? And even if you don't take anything, just take c equal to 100. So this would be 100 into n to the power 4, right? So 100 into n to the power 4. So now here, when it is 100 into n to the power 4, then in this case, even for n equal to 1, it would be correct, right? This would be 1 plus 2 plus 30. This will be 32. And this would be 100. So when c is equal to 100 and n equal to 1, then also it is correct. Getting it? Clear? So there can be multiple values, okay? You don't have to get stuck with one value. For any c and any n, if you prove it, that means that function g of n becomes, let f of n become big O of g of n or omega of g of n. If you prove that for any c, any n, it can become that. Again, all this is bookish definition. Just remember that whichever is the highest term, you just have to go with that. Clear, guys? Ready for some exercise now? Okay, so let's do some exercise now. Okay. So guys, let's take some examples now. So all that we'll be doing is we'll be taking iterative algorithm. So let's take this algorithm for I equal to 1, I less than n, I plus plus, for j equal to 1, j less than n, j plus plus, and let's say here we have print hello. So guys, what would be the running time of this algorithm? Now guys, just see this. If you have to determine the running time of this algorithm, you just have to figure out how many times the innermost statement will be printed. Okay, so here इसमें बताओ what will be the number of times this print statement would be printed? This print statement would be executed. What would be the number of times? Think about it. Come on guys, what would be the running time? Everyone is saying n square, but just think about it. Okay, instead of doing n square, just tell me how many times this print statement would be printed. Come on guys, just tell me that. How many times? I don't want the big O notation. Just tell me how many times this print statement would be printed. Okay. So people are saying 2n, n square. Okay, let's figure this out. Okay, see this. When I is equal to 1, then it would be printed n times. When I is equal to 1, then it will be printed n times. Yes or no? When I is equal to 2, then also it would be printed n times. When I is equal to 2, then also it will be printed n times. When I equal to 3, then also it will be printed n times. Let's do it less than equal to. Yeah, so then also it will be printed n times. when I equal to 4, then also it will be printed n times. Similarly, when up to when I is equal to n, then also it will be printed n times. Is it clear to everyone? Come on, guys. Okay, so total how many times? So this would be n plus n plus n plus n plus n. And how many times this n would be printed? N times. So total it would be n into n, right? What is it? It is n square. Yes or no, guys? It is n square, right? So what would be the running time of this algorithm? Come on, guys. What would be the running time of this algorithm? It would be n square. Very good. It will be big O. Guys, please, whenever you do running time, right, it would be either big O or omega, whatever. Always do it in big O unless specified. It would always put big O of n square. Running time is always given, the time complexity is always given in big O of n square. Okay. That is the notation. Clear? Okay, now guys, I'll just make a slight change in this. Here, instead of saying j less than equal to n, I would just say j less than equal to I. Now, can you tell me what would be the running time of this algorithm? I equal to 1, I less than equal to n, I plus plus, j equal to 1, j less than equal to I, j plus plus. So now can you tell me what would be the running time of this algorithm? Come on guys, quickly. Okay, so don't worry what is the running time. Let's calculate how many times print will be printed. Now, when I equal to 1, how many times it will be printed, guys? When I is equal to 1, how many times this print statement will be printed? Think about it. When I equal to 1, how many times this print statement will be printed? Don't worry about time complexity, guys. Just think about it. When I is equal to 1, so I equal to 1, I less than when n is equal to 1. Okay, sorry, not n. Let's say n is equal to 10. Let's say when I is equal to 1. So how many times this hello will be printed? When I is equal to 1, how many times? One time, right? So I equal to 1, I less than equal to 10. It goes inside the loop. For j equal to 1, j less than equal to I is equal to 1. So j equal to 1, j less than equal to 1, j plus plus. So it will only print one time, right? Now when I is equal to 2, how many times this statement would be printed? So I equal to 2, I less than equal to n. Okay. So j equal to 1, j less than equal to 2, j plus plus. So j equal to 1 and then j equal to 2. Then it will be printed 2 times, right? Clear, guys? When I equal to 2, this hello will be printed 2 times, right? Come on, guys. Yes or no? No, if you're not understanding, please write it in the chat, yaar. Guys, is it clear? So I equal to 2, it will be printed 2 times. When I is equal to 3, how many times this will be printed? 3 times. When I equal to 4, how many times this will be printed? 4 times. Similarly, when I is equal to n, how many times it will be printed? When I is equal to n, how many times? Guys, when I equal to n, how many times? N times. Right. So total how many times? Total 1 plus 2 plus 3 plus 4 plus 5 plus n. Yes or no? Total these many times, right? So now what is this sum? Sum of first and natural numbers. What is the sum of first and natural numbers? n into n plus 1 by 2, right? Now, if this is the f of n, then what is the time complexity? We have already discussed this. If this is the f of n, then what is the time complexity? Guys, if this is f of n, what is the time complexity? N square. Guys, again n square, big O of n square. Okay, now next time if anyone answers n square or n cube in time complexity, then they have to sing a song, okay? Clear? Okay, fine. So time complexity always, guys, put it in big O terms or omega terms, but don't say just n square, okay? Cool. Is it clear, guys, how this became n square? Okay, now next question, guys. For I equal to 1, I square is less than equal to n, I plus plus, print hello. So you have to tell me what is the time complexity of this function. Come on, guys. How many times will this be printed? What is the time complexity of this function? Come on. Think about it. You can answer this. Very good. It is big O of root n, right? See, I square less than equal to n can also be written as I less than equal to root n, right? Yes or no, guys? This is the same thing, right? Yes or no? Can we write it like this? We can write it like this. So what will be the time complexity? It would be big O of root n, right? That is the number of times this print statement will be printed. Clear? Clear, everyone? In the chat? Okay, fine. Now, guys, we are going to a difficult question. Let's see whether you will be able to answer this or not. So now it is like for I equal to 1, I less than equal to n, I plus plus, and then for j equal to 1, j less than equal to I, j plus plus, and then within this we have for k equal to 1, k less than equal to 100, k plus plus, and then here we have console.log hello. So this is the last question for the day, guys. Then we'll move to the doubt session for 10 minutes. Right, so this is the last question. Can you tell me how many times will this console.log hello will be printed? Think about it, guys. How many times this console.log hello will be printed? So always I will suggest, if you are beginning, right, always go for numbers. So let's say when I equal to 1. So when I equal to 1, how many times will this be printed? So I equal to 1, then here this loop will run one time. J less than equal to I, this loop will run one time, and this loop will run 100 times. So this will be printed 100 times, right? When I equal to 1, this will be printed 100 times. Yes or no, guys? Okay, now when I equal to 2, then how many times this would be printed? So j equal to 1, j less than equal to I, j plus plus. So this will be printed 100 plus 100 times, right? 100 times and plus 100 times. So this will be printed 200 times, right? When I equal to 3, how many times, guys? When I equal to 3, how many times? 300. Very good. Now when I equal to n, how many times? Come on, guys. When I equal to n, how many times? N into 100 times. So total how many times, guys? Total 100 plus 200 plus 300 plus up to n into 100 times. So let's take 100 common. This would be 1 plus 2 plus 3 plus n. So it would be 100 into n plus 1 by 2. Yes or no? So this will be 50 into n plus 1. Right, 50 into n plus 1, right? 50 into n plus 1. So guys, what is the time complexity here? Come on. 50 into n plus 1. What is the time complexity? N to the power 100. How? Here 50 into... Here see, 50 into n plus 1 is what? 50 into n square plus n. So this is nothing but 50n square plus 50n. I have told you to reject the coefficient no matter how large it is. Just reject the coefficient. Now, which is the biggest term? This is the biggest term, right? So this is big O of n square, right? Guys, is it clear? It is big O of n square, right, guys? I hope it is clear to everyone. Okay, now, yeah, you have confused me a little bit. So I'll take one more question. Okay, so now I was thinking that it is clear, but now I think it is not very clear. So let me just take one more question. I equal to 1, I less than equal to n, I plus plus. Okay, second one is for j equal to 1, j is less than equal to I square. This is a tough question. J plus plus. And then we have for k equal to 1, k less than equal to n, k plus plus. And here we have console.log hello. So guys, in this case, can you tell me what is the time complexity? Just take 10 minutes to figure this out. And just see, it's not big O of n definitely. Just try it for some time. Just see how many times this log statement will be printed. When the value of I is 1, when the value of I is 2, just think how many times this is going to be printed, and based on that, come up with the answer. Okay, n cube is also not the correct answer. N square is also not correct. We go of 1. How, bro? Okay, big O of 2n. Okay, I think one correct answer. Let's figure this out. Okay, now guys, see this. This is the algorithm. So what we need to do is, let's see this. Now for I equal to 1, I equal to 1, how many times hello will be printed? So for I equal to 1, when I is equal to 1, so this would be I equal to 1, I less than equal to n, j equal to 1, j less than equal to 1. Now this would be k equal to 1, k less than equal to n. So when I is equal to 1, right, when I is equal to 1, how many times hello will be printed? Come on guys, in the chat. When I equal to 1, how many times hello will be printed? N times, right? N times, because this is k less than equal to n, right? So n times hello will be printed. Is this clear to everyone? Come on. N times is clear. Yeah, see, when I equal to 1, so this will be I equal to 1, I less than equal to n. It will go inside this loop. For j equal to 1, j less than equal to I square, I is 1. So I is 1, right? When I is 1, when I is 1, j loop will be executed one time because I square. And this loop will be executed how many times? So this is k equal to 1, k less than equal to n. So the k loop will be executed n times, right? Okay, so the k loop will be executed n times. So the total time this loop will be executed will be n into 1, right? So this will be executed n times. Now when I is equal to 2, what will be the value of j? So this j loop will be executed how many times? When I is equal to 2. J loop, guys. J loop will be executed how many times? 4 times. This k loop is executing n times only. So total how many times this would be executed? It would be 4n. Right, guys? When I is equal to 2, when I is equal to 2, this will be j equal to 1, j less than equal to 4, j plus plus. So when j equal to 1, j less than equal to 4. So when j equal to 1, this will run 100 times. Or let's say n is equal to 100, this will run 100 times. J equal to 2, this will run 100 times. J equal to 3, this will run 100 times. J equal to 4, this will run 100 times. So 4n, right? Clear? Yes or no? This is clear? Okay. Now when I equal to 3, then what is the value of j? It equal to 9, right? So this will run 9n times. Yes or no? Similarly, the next, you have got the pattern. If I equal to 4, then it will run 16n times. Got the pattern? Okay. So total how many times this will run? This will run n into 1 plus 4 plus 9 plus 16 plus so on, right? Yes or no? Guys, this is what? Okay. Now, this is nothing but the sum of the squares of first and natural numbers, right? So this will be 1 square plus 2 square plus 3 square plus 4 square plus so on, right? Up to n square. Right. This is nothing but 1 square plus 2 square plus 3 square plus 4 square plus up to n square into n. Now, guys, do you know the formula for this? The square of first and natural numbers? I already showed you at one place, but I didn't tell you this is the formula. The formula is n into n plus 1 into 2n plus 1 by 6. Okay, so this is the one. Now, guys, if you see this, out of this, the biggest term will be n cube. When you multiply n cube by n, it would be n to the power 4. So the time complexity for this is big O of n to the power 4. Clear, everyone? Others, is it clear? On a scale of 1 to 10, how clear is it, guys, in the chat? Come on, guys. On a scale of 1 to 10, how clear it is? Come on, everyone. Please answer this. Here, see, do you think whatever we are discussing now is easy? It's not easy. I can tell you for a beginner, it is not easy, guys. And I want you to take pride in the fact that at least just after 2 hours, you are able to give it a 6 or a 7 or a 5. Maybe it's clear, maybe it's not clear, right? But with practice, every day we are going to do sums like this. Okay. Only thing that I'm requesting from you is please be a little bit more interactive in the chat. If you're not understanding anything, please feel free. No one is there to judge. है ना? Please feel free to just let me know that you're not able to understand it. You have paid money for the course, so it's your right to actually understand things, right? If you're not understanding something, it's my job to make you understand things. Okay, so please be a little bit more interactive, and guys, always I'll tell you, please take a little bit of pride in the fact that you have actually understood so much, and this is just 2 hours. We are going to meet so many times. Okay, so the amount of learning is going to be huge, but guys, please don't only be dependent on me. Okay, go try to solve some sums, read something about time complexity, right? Try to understand how it works, and later on with the algorithms that we'll be discussing, right? For every algorithm, we'll try to determine the time complexity as well. Okay, so that is it for today's session. We'll take 10 minutes for the doubt, guys. I'll also launch the end session poll. But I hope, guys, everyone found the session useful. Guys? Okay, fine. One request here, please, whatever doubts you have, just be, just keep on telling me the doubts. Okay, so just do that. Okay, cool. Cool, guys. I think that's it for today. When is our next session, by the way? Does anyone know that? I'll just let you know. Let me check. Yeah, next session is on 18th. So yeah, let's meet on 18th, guys. Okay, I'll just launch the poll, right? Guys, please, any feedback, anything that you like, did not like, please mention it here, right? I can look at it and maybe take actions if you're not understanding anything, right? but please do a little bit of practice before the next session. Okay, guys, I think that's it for today's session then. Let's meet again on 18th. Till then, I hope you'll practice a bit. Just go through the session, try to, change the values of these for loops, right? Just try to figure out what would be the output when you change the value. For example, just see this here, right? Instead of, let's say, n, what if here we had n square? In that case, what would be the time complexity? Right here, let's say, what if we had I less than n by 2? So what would be the time complexity? So go through the lecture, try to change these values and figure out whether the time complexities are correct or not. If you want to discuss any doubts in the next session, for the first 10 minutes or 10-15 minutes, until all your doubts are resolved, will not move forward with a new topic unless all your doubts are resolved. Okay, so let's do that. By the way, guys, which programming language are you comfortable in? I hope it's JavaScript, right? What about others? Okay. And what is the language that you are being taught in the course right now? Okay, that is Java. Cool. Okay, so I'm basically a JavaScript developer, right? But for DSA, you only need the algorithms and how do the algorithms work, right? You try to understand the logic more than how to code it out, right? But because the course language is Java, right? I would also try to learn some Java. Uh, Basically, we could do the algorithms in JavaScript as well, but because you are familiar with Java, let's do it in Java itself. So from the next session onwards, let's do the questions and solve the questions in Java itself. Okay, cool, everyone. By then, hope you enjoy your weekend. Goodbye, guys.